In today's tutorial, we will discuss the question, how can we achieve the inversion of a stereogenic center with the example of a secondary alcohol. Here we have the R enantiomer, and we would like to achieve the inversion to the S enantiomer. We have a couple of reagents suggested for this transformation. Your task is to think about which reagent should I apply in which sequence of reagents. Try to solve the problem first by yourself and please listen to my explanation afterwards. The reagents we have is, first of all, paratoluene sulfonic acid chloride, abbreviated as TOS-Cl, sodium acetate, pyridine, methanol, and potassium carbonate. As you know, a hydroxyl group is not a good leaving group. But esters, sulfonic acid esters of alcohols are good leaving groups, so it is a good idea first to synthesize the sulfonic acid ester. For instance, the tosylate. You need, of course, the sulfonyl chloride and pyridine as a base to trap the formed HCl, and more important, to activate the nucleophilicity of the alcohol oxygen by first forming a hydrogen bridging bond to that proton as the first step of the deprotonation. Next step could be just applying potassium or sodium hydroxide to achieve the SN2 process directly to that product. However, it is a good advice to avoid strong bases like hydroxide, because with strong bases you are in danger to lose material to elimination processes. Therefore, we should take sodium acetate in appropriate solvents like DMF and DMSO. You can easily achieve a nucleophilic substitution with sodium acetate, and it will take the root of an SN2 reaction with an inversion of the stereogenic center. And how do we achieve the last step of the transformation? Either by hydrolysis, but basic or acidic hydrolysis of an ester can also lead to competing reactions. The best yield we should achieve by a trans-esterification. We take methanol in in the presence of a base, potassium carbonate, then the methanolate will react as a nucleophile addition, elimination, reaction. We will get acetic acid methyl ester as the byproduct and a free secondary alcohol. This is the classical way of achieving such an inversion at the stereogenic center of a secondary alcohol. A more modern method you can find under the name Mitsunobu reaction, and it is a good idea to compare the more complicated but modern Mitsunobu reaction to the process we had just discussed. Thanks for listening.